Hi all, and this video we will discuss about delete an item from the first of the linked list. So that is the first one, and at the same time we need to discuss how to delete item from an end of the list, and we will talk about the complexity also. So we can start. For example, first I want to delete this node 10. Okay, this node 10 from here. So this is my aim, and what will do? The remaining, this will be the new list. This is my aim. So you can clear this one. I need to delete the node, one node from the first of the linked list. So how we can do? It is very simple. We can do this part is head dot next. Okay, so we can simply return the head dot next. Then we will get this one. So this much is simple as the code. You can see here. For example, we created the linked list, not 10, not 20, not 30, not 40. Okay. Then what we do, we call this one. Then we get 10, 20, 30, 40. This is the linked list. Then what we do, we will call the delete first. So here, if head equal to none, there is no item present in the linked list, we can simply return the none. Else, what we do, we will return the head dot next because we cannot delete. We don't want to delete this item. We can just want to this portion only. So that means the head dot next. Head is this one. Head dot next means the all thing, right? So that is the reason we will return the head dot next here. You can return head dot next. This is the simplest form. Then we can printing the this one. The println list mean current we are assigned to, then while condition process until the none. So this is the one we are using at the deleting item from the first of the linked list. It's very easy. You already know. And the time complexity means you already okay, you can imagine, right? Bigger of one. There is nothing we need to do. The element, first element, we just remove. Not remove, we just we don't want to take that one. So just pointing to the next variable itself. So that means big of n, and we are not saving any recursive thing. That is the reason it is the auxiliary space also bigger of one. So this is the only one point we need to check. So I will write here for the better understanding. Yes, so this is the first condition if head equal to none. And this one also has 2. So head return head dot next. Okay. So delete the item from the first of the linked list, this one. And the next one we want to delete at the same time we want to delete from the end of the linked list. So you already know how we can check this one. Condition is that okay. Condition is that I want to remove 40 from the linked list. So I want to remove this one, right? So this is my condition. So I know 10, 20. First, oh, we already know how to find the last element and remove it and the node. This node and next one will be none. So these are the 3 points we need to done. So it will how it will work. For example, you already know if head equal to none, nothing. Just return the none. And if head dot next equal to none, that means only one element. That time also you already know. Just remove it and return it. That is the reason. 2 times return. If there is no element, if it is one element, the same thing, return that. But if the element is present, we want to iterate. That means here current equal to head and current dot next. Not next. Because, for example, so this is the current. Current dot next means this one, and current dot next means this one. So why this is calling? For example, current is here. It is checking from. We need to delete this one. So current dot next means 40. Current dot next one will be none. That need to check. So that is the reason current dot next not equal to none. Then until that point of time we can execute next. But if we find this option, it means current dot next, what we do? current dot next equal to none. That means the pointing to that one and return head. That means we can simply delete current. This one is current. Here current dot next equal to 40 dot next equal to none. So that time we will do current dot next equal to none. This position we are dot next equal to just assign into none and return head. So that is just want to find the last element, then current dot next equal to none assign. That means the element removed and it will be returned. So that is the all idea regarding the delete at the end of the linked list. Then the time complexity means we need to iterate at the end. We need to find the end. So that means bigger of n, and the space complexity, that is we are not storing anything. So bigger of 1 is the space complexity. And if we sustain one variable, like this is the n, this is the first one, so this is very easy. So we already know this much of this is the index will be the end point. So that end point we can identify easily, remove this iteration step. So we can, time complexity will be bigger of 1. At that case, if we sustaining one variable there that has the value at the end position, then easily there is no need of while condition. We can assign the bigger of 1 will be, we can do that. So this is the whole idea regarding the deleting at the end of the linked list. If you have any doubt, you just comment below. We can see in the next video. Okay.